Hello everyone, welcome to the Introduction to Mechanical and Industrial Engineering course, Mech 130. This is Dr. Muhammad Chat. In this video, this is part 2 of the mechanical design. Over the previous video, I've introduced for the mechanical design or engineering design. The focus of the previous video actually was on the engineering design or design from the general perspective of engineering. I've discussed the engineering design procedure. I've applied the procedure over in order to design a mechanical system that would be used for lifting a car. This is what we covered over the previous video. In today's video and the next coming videos actually, which are related to the mechanical design, the focus is going to be on the type of knowledge that you should have to be a mechanical design engineer. Or in other words, in order to be able to design mechanical system, what type of knowledge that you need. This is what we're going to explain or discuss over these videos starting from today's video. Make sense? So these are the different topics that we are going to discuss. If you remember in the general procedure of the engineering design, there were some steps. Some of these steps were collect information, concept generation, and recommended design, if you remember that, right? So, and even we define these different steps. For example, in collecting information, it means that you collect any kind of information that would be helpful and assist you in order to design the mechanical system that is assigned to you, right? Concept generation, it means that you're gonna come up with different ideas, collect the ideas, record them, right? Then recommend one of these designs to be the suitable design for the mechanical system that is assigned to you, right? So in order to perform these steps, you should have some knowledge. It is not any other engineer with zero knowledge in mechanical engineering who could do these things or that would be used for the design of mechanical system. In order to be able to design mechanical system, or in other words, in order to be able to perform these steps in your design procedure, you require some fundamental knowledge which are related to the engineering systems in general, mechanical engineering system or machines in general, and what are their components or elements. So for example, if we're going to talk about the car and you are assigned to design something related to your car, so at least you should know what are the different components of this car, what are the different mechanical elements that would be used for making this car, how this car is working, how the transmission system of the car is working. So this essential information, you should know them. You should know this information. At least you could be able to perform this step, and this is what we are going to focus on over this part. So starting from today's lecture, we're going to discuss the important or the different types of machine elements and their function. So we do have gears, shafts, clutches, couplings, bearing, belts, chains. So what are these different mechanical components and what is the function of each one? This is what we are going to discuss starting from today's video. Then we are going to discuss the transmission system, and we're going to consider the example of the manual car, like how the transmission system of the vehicle is working, how we could shift gear between the first gear, the second gear, the third gear, how we can shift between these different gears in the car. This is the entire transmission system of the car. We are going to discuss this thing as well. And how it works, this is what will be discussed as well through this part. This first part will be covered in around 2 videos till we finish this part. Then also one of the steps that was explained in the mechanical design procedure is detailed design and analysis. It means that one of the things that you should do some design calculations, if you remember, and this requires some knowledge as well. In order to do this calculation, you should have some fundamental knowledge so you could able to perform this step. These calculations would require some knowledge about the unit system and their conversion, force analysis, stresses, tensile stress, engineering material dynamics, factor of safety, and so many other things which are related to the engineering mechanics in general, related to the material science and the mechanical design. So these things also will be discussed. So we are going to explain what does it mean stress, what does it mean force analysis, and how we can do some force analysis to some simple mechanical system. What does it mean tensile test? the engineering material. These topics and keywords will be discussed, and it will be much more clear as we move on through this part. This also will be covered in around 3 to 4 videos or lectures till we finish this part. Then also one of the steps of the design procedure is the communication. Is just to communicate with somebody else about your design, to convince your supervisor about your design. This is also one of the steps that have been explained over the previous video, right? So and we mentioned that one of the best proper way to, in order to communicate your design with other engineer or supervisor is through graphics and engineering drawing. So this topic also will be covered, but once we finish this part, these first two parts. Also manufacturing, one of the steps of the engineering design is to manufacture your design. You design the machine, you design some things, you have to move to the production phase, right? And this would require some knowledge as well in the manufacturing engineering or the manufacturing processes, and this is the responsibility of the manufacturing engineer or the production engineer, which this topic is more related to both mechanical and industrial engineering as well. Make sense? So this, you could say that this is the plan over the next month or so till we finish these parts. Then we're gonna move to other topic, which would be the fluid mechanics. Make sense? So these are the different topics and points that we are going to cover, which are related to the mechanical design over different videos. Today we're gonna discuss some of the machine elements, and we're gonna know their function. Then the next video or the next lecture, we're gonna continue over this part, and in the meanwhile, we're gonna discuss the transmission system and their operating principle. Make sense? So this is the first part, machine element. So we should understand, what does it mean, machine element? What does it mean, this word? Or in other words, we can give it a name as mechanical element. So something that you should acknowledge or distinguish between machine element or mechanical element and mechanical system. So the difference is it element or system? So what is the difference? It is very simple. If we're gonna talk about the entire machine, it is a system. It is a mechanical system. Why mechanical? Because it is related to mechanical application. Since we're gonna talk about machine, your car, for example, your driving car, it is a machine. And it is a movable machine. It is not fixed in place, but it is still a machine that is movable, yes, but it is a machine. So the car itself, it is a machine, and it is qualified to be a mechanical system. Because why mechanical system? Because the mechanical system, it is composed of different mechanical elements. It has so many mechanical things inside it. If you're gonna look to the transmission of your car, you're gonna see so many gears. Every single gear, it is a mechanical element. But the entire gearbox, it is a mechanical system. Why? It consists of multiple mechanical elements. So the mechanical system in general, it is a composition of different mechanical elements. But this thing that can be separated individual by itself, it is just one single element of this entire system. So that's why it is named as machine element. So the machine element, it is a component, or the mechanical element, it is a component, one single component of a mechanical system, like a machine, like the car, for example. Bicycle, your bicycle, for example, one single wheel of the bicycle could be considered like one element, but the entire bicycle, it is a machine. It is a mechanical system, and so on. So the mechanical system, it is a composition of multiple mechanical elements. Anything that can be separated by itself as a single unit, and it cannot be broken down into any other elements anymore, it will be counted as mechanical element or machine element. So the machine element, it is the thing that is unbreakable anymore. The thing that is individual, the thing that is single, that cannot be separated into multiple parts. Like, for example, if we're gonna consider this pen, this pen could be considered as a mechanical system. Why? This part, it can be separated, right, as a single part. So this is one single part. So I can count this one as a machine element. But when we assemble this part to the bin, the entire bin, it is a system. It is a mechanical system that consists of one part. Even you can remove this tab here in the bottom. This is gonna be another part. The core inside is another part. The tip here, it is another part. So anything that can be separated, it is a mechanical part. It is a mechanical element. When you assemble all of these parts together, you're gonna end up with a mechanical system. Very simple. Make sense? So this is how we distinguish between a mechanical system and a mechanical element or a machine element. So the objective over this part here is just to know the different types of machine elements that would be used to assemble an entire machine, that would be used for making an entire machine. So we're just gonna focus on the elements, not the system. We're gonna focus over the different elements that would be used for making a machine. This is the objective of this part. So machine elements, parts that would be used for making machine, could be grouped into three basic types. There are some structural elements, and I'm gonna explain to you what does it mean structure, and there are some other elements which are mechanisms, and there are some other elements which are qualified as controllers. So these are the three types that we are going to discuss. We're gonna discuss some of them over this video, and we're gonna continue the next video. So these are the three main types of components that would be used for making any machine, whatever it is, in general. So in general, the machine elements that would be used for making a machine are three groups: control components that used for controlling things, and some other component that would be used as mechanisms for making a mechanism, and there are some other components which are structural component. Let us start with the structural component. What does it mean structure? To understand it, you should acknowledge the difference between a structure and a mechanism. Structure is something that is immovable, that cannot move, that is stationary in place, has zero movement. It will not be moving. This is the structure. Like if we're gonna talk about a building, if we're gonna talk about a bridge, these things are structures. Structure, it means that they are not moving, fixed things. They are not movable things, so these are a structure. So any component inside any machine that is not moving, it is a structure. It will be considered as a structural component or a structural element inside that machine. Examples of these structural components are so many, as we are going to discuss. But what is a mechanism? We said that there is a difference between a structure and a mechanism. Structure is something that is immovable, that cannot be moved. A mechanism is something that is movable. A mechanism is what makes a machine. For example, what distinguishes a machine from a bridge? The bridge, it is a structure that cannot move. It is fixed, it is stationary in place. But a mechanism is the thing that makes a machine. The machine, it contains mechanisms. So what distinguishes? For example, if you have a machine in your company, for example, the machine is fixed in place. The machine itself, it cannot be moving, right? It is just fixed in place, but it is a machine that contains mechanism, contains some mechanical element, and these mechanical elements are movable inside it. So the core of the machine, it moves, but the bridge, it is stationary. The entire bridge, it is stationary, even it has no component that are moving inside the bridge. So the bridge, it is a structure. But if we're gonna talk about the machine, it is a machine that contains mechanisms plus structural component. There are some components inside the machine that is stationary, that are not moving. So these are a structural component. Plus there are some other components that are moving, like gears, shafts, other things. These are movable components to form a mechanism. So they gonna be qualified as mechanisms elements, or element for making a mechanism. Make sense? So the machine elements are either structural component or component that used for making mechanism, or other component that will be used for the controlling system of that machine, as it will be explained over the next slides. Make sense? let us discuss here the structural component, the component that are stationary. The main objective, the first function of any structural component is to give support to the other component, especially the component who are movable. So again, the structural component itself, it is fixed, is not moving. But its main function, its main objective is to give support to the other component who are moving, who are making mechanism inside the machine. Like for example, the frame members, like this one. This is a frame. This is a typical example of a frame member. This is chase of the car. If you're gonna look underneath the car, you're gonna see something like this thing. This thing is made of a steel structure. This is like frame membrane that gives a support to all the entire car. The wheels of the car, the shafts that gives rotation to the car, the transmission system of the car, the engine of the car, the body of the car, the chairs, all the details of the car are supported over this frame. So this is a structural component. Itself is not moving. There is nothing here is moving. There is nothing here is a mechanism, right? But it gives support to the other components like wheels, braking system, engine, transmission system, and so on. So it supports the entire car. So it is used for supporting the other component who are moving inside the machine. This is one of the structural component, which is the chase of the car. Make sense? Bearings, also one of the types of the structural components. What does it mean, bearings? You should acknowledge and understand what does it mean, bearing. The bearing, it is a structural component as well that gives support to a rotating shaft. As we mentioned, in a structural component, it should give support to something that is movable inside the machine. One of these important structural components are the bearings. So all of these are different types of bearing. This is a bearing. This is the same type of bearing. Also, this is an animation that shows you how the bearing is working. And this schematic shows the shaft and the bearing, and I'm gonna give more detail about this thing. And this is like the typical shape, the real shape or form of the bearing. So this is the bearing here. This is one bearing. And this is another bearing here. So these bearings, this is how it looks like in real, right? And the thing in the middle here, this is the shaft that I'm talking about. This shaft, it should be rotating. And I should provide like free rotation for that shaft. So the bearing, it consists of two rings. It consists of two rings. This ring, this is like outer ring. And we do have an inner ring. So the thing inside here, this is the inner ring. So the bearing in general, this is, here I'm talking about the conventional form of the bearing. It consists of an outer ring and inner ring. Usually what happens is that this outer ring, it is fixed to the gearbox housing. So this detail will be much more clear as we move on in the next slides. But remember that these bearings are commonly used. One of the important mechanical components in a gearbox is the bearing. This bearing is fixed in the housing. This housing, this is the housing that I'm talking about. This is something that is stationary. This is like a structure. And these are the bearing. The bearing, it has two rings. One ring, which is this external ring, and this is the inner ring. The thing inside, this inner thing, this is the inner ring. So the outer ring, it is fixed to the housing. It means that this outer ring, it is immovable, cannot move, fixed, stationary. And there are some inner balls. These are small balls. So that's why this type of bearing is known as ball bearing. These balls are free to rotate, inside the inner space between the outer ring and the inner ring. This inner ring in the middle here, it is free to rotate. So what's happening actually that we fix this inner ring into the shaft, or the shaft is gonna be fixed inside this inner ring. Both they're gonna be fitted together, mounted together, hold together. So you do have the outer ring fixed, stationary, immovable, and you do have the shaft that is fixed in the inner ring. Now, if you try to give rotation the shaft, the shaft will be freely rotate because of these bolts. These bolts gonna give free rotation, easy rotation with zero friction of the shaft with respect to the or the inner ring with respect to the outer ring, or the shaft with respect to the housing of the gearbox. Why? Because one of the problems of mechanical system in general is the friction. The friction is heat and energy dissipation. It means that it means to get rid of the friction, you have to apply more energy. You have to exert more effort, and as much as you exert more effort and energy, this means cash. It is pricey. It's gonna take a price to get rid of the friction. So one of the things is the bearing to get rid of the friction, is to allow for the easy rotation, for the smooth rotation, for the free rotation of the shaft with respect to the housing of the gearbox, and it's gonna be much more clear as we move on in the next slides. Make sense? So as you can see here in this animation, we do have the outer ring, it is fixed, while the inner ring is the thing that rotates, and because it contains some balls in between, these balls gives free rotation. So the friction here almost zero, very negligible friction, and this saves more energy, saves more effort, and allow more efficient function of this shaft to give rotation. So that's why the bearings, while they would seem they are movable, the inner ring is moving, right? So they would seem as movable, but their main essential function, they are giving support to another movable part, which is the shaft. So that's why they are grouped as a structural component. So remember that the structural component is a mechanical element that gives support, that in many cases in immovable, that gives support to other mechanical components who are moving. Like this bearing gives support to the shaft. The shaft is the thing that moves. So that's why the shaft, the bearing, it will be classified as structural component. Make sense? The next component is axles. Axles, these also are the things like one of the typical example of the axle is the axle of your car, of your bicycle. This is the typical shape of the axle in a bicycle, if you acknowledge this thing. So this bolt with the entire shape, this entire thing that is shown in black here, this is the axle of the bicycle. And that gives support to a rotating wheel. The bicycle, it has two rotating wheels, right? So the wheel of the bicycle to rotate, it should be supported by an axle. This axle, this is a structural element. Why? Itself is not rotating. It is not rotating at all. It is just fixed and gives rotation to the wheel that is gonna be mounted or fixed over this axle. So that's why it is a structural component. It is not a mechanism. Itself, it is immovable, but gives support to another component, which is the wheel of the bicycle, to give it free rotation. This is the function of the axle. If you had a chance to open this axle, it has multiple parts. So you could deal with this one like a system, not just one single component. It means that it can be separated into multiple parts. Like for example, if you have had a chance before to remove this outer thing, this cylindrical part from the inner axle itself, you're gonna find inside it there should be a little bit small balls. This ball give free rotation, the same idea and the same concept as the bearing. So the axle is one of the structural components as well that gives rotation or support to a rotating element in many of the cases, like wheel, like the example of a wheel in the bicycle. Also, this axle that is used in vehicles, on car, I'm pretty sure some of you had an idea and have a look to this shape before. These are the two wheels of the car. And here we are talking about rear wheel drive vehicle. Rear wheel, it means that the two wheels in the back, they are the thing that gives drive to the entire vehicle. So this type of vehicle is known as rear wheel drive vehicle. that it has two wheels in the back, and these two wheels are supported by an axle in the middle. So this thing, this entire thing here, this is the axle that I'm talking about, which is like this one. Here, for example, you're gonna fix these bolts that projected here. You're gonna fix one wheel, and from the other side, you're gonna fix the other wheel, and this will be connected to a big shaft that gives the driving motion from the engine in front of the car to give drive to the rear wheel of the vehicle. So this black thing, this entire thing is commonly known as the axle. This is what used in the car. This axle itself, it is not rotating. It is not rotating. It is stationary. There is no rotation here, but it gives support to the wheels that are rotating. And another thing that you should understand, if you had a chance to open this thing and look inside it, there is inside this axle, there is a little very thin or small shaft that's rotating. It means that inside this thing, this is like a container. This is like a box. It is empty inside it. There is something inside it. Through the entire length of this axle is a shaft. This shaft gives rotation to the wheels. It gives support, this axle gives support to two main things. Gives support to the shaft that is going to give rotation to the wheel, plus it gives support to the wheels themselves. If you have a car and you had a chance to look at this system before, you're going to find that this disc is rotating. This disc should be rotating. And the other disc on the other side also as well, it should be rotating. So for these two discs to be rotating, there should be in the center here, there should be a shaft going all the way inside this box, which is not seen. It is internal, it is inside it. So when this shaft rotates, it's gonna give rotation to this disc and rotation to the other disc. On these discs, we're already fixing and mounting the wheel, so this is gonna give rotation to the wheel of the vehicle. So this is the axle that I'm talking about of the car. So axles in general, they are like our mechanical component that they are immovable. They are not rotating, non-rotating elements, mechanical element that they give support to other mechanical elements who are rotating, who shall be mounted on them. Like for example, the axle in the bicycle, it's gonna give support to a rotating wheel of the bicycle. The axle in the car is gonna give support to the rotating shafts and the rotating wheels of the vehicle or the car. So this is gonna be the axle. Make sense? So these are some of the mechanical components as well. Also splines and shafts. Splines and shafts are very similar. Some of the people gonna give them the same name as shafts, but the general name actually is shaft. And something that distinguishes a shaft from an axle, if we just discuss, because here we discussed this is a shaft, right? The shaft, it is a rotating mechanical element, something that rotates. And any shaft to rotate, it requires two bearings to give him support. So again, any shaft to rotate, it requires two bearings as this shaft. So this shaft, it is a rotating shaft. It should be supported by one bearing from one end, another bearing from the other end, and the shaft, it will be freely rotating between the two bearings. You're gonna fix one bearing from this side, another bearing from this side, then you're gonna give rotation to the shaft in the middle. The outer ring of the bearing will be fixed to the housing of the gearbox, and this one will be fixed, but the inner ring is free. So when you try to give rotation to the shaft in between, it will be freely rotate. This is the basic idea of the shaft. What distinguishes the shaft from an axle is the axle is non-rotating. The axle, it would seem the same shape as the shaft. It would have the same shape, very similar to the shaft shape, right? This is the shaft and this is the axle. But the big difference is that the axle is non-rotating mechanical component and it gives support to other mechanical components who are rotating. But the shaft itself, it rotates. This is the big difference or the essential difference between an axle and a shaft. Make sense? And the shaft to be supported, it requires two bearings to support it, at least two bearings. Usually two bearings are used for supporting a shaft. It is not possible to support a shaft with only one bearing. You should use two bearings at the two ends of the shaft to give it support. Make sense? So this shaft, it rotates, and the shaft itself, it will be used for mounting gears and other things, or fixing or giving a support to gears. But the shaft itself, it rotates. Make sense? So what is this spline? The spline, it is a shaft, but the shaft, in case like this case, this shaft, it is a shaft with a spline. Like this spline, it is shaped and crafted over the shaft. This is like kind of this part from here to there, this entire length, it is blank. There is nothing here. It is a smooth cylindrical surface of the shaft. But if you can see and observe this part, this is a spline. This part, it is specially shaped. It is a special shape that have been crafted over the outer surface of the shaft. This shape, it is known as a spline. This spline, it will allow for the direct mounting and fixing other component like gears over the shaft directly, and it's gonna be cleared as we move on. But for now, you should acknowledge or understand that this shape, this entire thing, it is a shaft. This entire thing, it is a shaft. This part is the spline of that shaft. This part is another spline of the same shaft. But what is the thing in between here? This thing, it is a gear. So you should acknowledge the difference between the gear and the spline. They would seem the same shape as a feature, but both the spline and the gear both are crafted, are manufactured, are shaped over the same shaft. All of this thing is one single unit, is one single part. It has a spline, it has gears. This entire shaft is commonly known as a spline shaft, just to distinguish from the blank shaft. So this is, for example, this shaft is a blank shaft, has no spline. This is thread, this is not a spline. These things here, it is cylindrical, like these tooth of the thread, just to allow for mounting this nut. So this is another mechanical component that we are going to discuss, but this is the thread, the screw thing, but this is not a spline. So this shaft has no spline, this is just a shaft. But this shaft here, this one, it is a spline shaft. Why? It is a shaft plus there is a spline that have been crafted over it. This is a spline, this is a spline. Like this case, this is thread, this is not a spline. As you can see, the spline, it is parallel. The groove of the spline, it should be parallel to the axis of the shaft. But the thread, it is cylindrical, it is rounded around the shaft. So this is a thread, not a spline. But this is a spline that it have been shaped and crafted over the shaft. This entire thing is the shaft. Make sense? This entire thing is the shaft. The other side here, there is a spline here. This is a spline. Why? The grooves are parallel to the shaft axis. This spline, this is a spline. Why? The grooves are parallel, but this thing is thread. This is thread. Make sense? What is the function of the spline? Or what is the function of the shaft in general? Usually, shafts are used to give support to gears. So as you can see, here we are talking about the structural component. So why we are including shafts despite it rotates? The shaft itself, it moves, it rotates, right? While it moves, we are including it as a structural component. Why? Because the main function of the shaft is to give support to another component who is rotating, which is the gear. Shafts are mainly made to support gears. What are the gears? The gears are one of the mechanical components that we are going to discuss with more detail in the next slides. Make sense? So the shafts are a structural component, despite that they are rotating and they are supported by bearings. So bearings are a structural component. Why? They give support to shafts. Shafts themselves are a structural component. Why? Because they give support to gears. Gears are rotating mechanical component. So that's why shafts are grouped as a structural component. Make sense? Shafts, the gears would be crafted into the shaft directly, would be manufactured with the shaft as a single part. In some other cases, we could fix the gear over the shaft. It means that the gear can be separated from the shaft and mounted back and removed back and so on. So it means that we can mount and remove a gear from a shaft. We can do it that way. Or we can manufacture or craft the gear directly to be one single part with the shaft. We can do both options. This depends on the size of the gear, depends on the size of the shaft, depends on other things. So we do have the two options. Like for example, this shaft has no gears crafted on it. It means that this shaft, it can give support to another gear. It means that you have to fix the gear. Like you have the shaft and you're gonna fix the gear over the shaft. Then once the shaft rotates, it's gonna give rotation to the gear. But this gear here, it is crafted over the shaft, manufactured with the shaft. Make sense? So again, the shaft, it is a structural component that used for giving support to rotating component, other rotating component who are the gears. Shafts would be made with the spline. The spline is a way of fixing a gear over a shaft, and it's gonna be much more clear when we move on to the next slides. Make sense? So it is highly important to acknowledge that this feature, it is a spline. This is a gear, this is another spline, this is a thread. Acknowledge the difference between these things. Also, the spline is commonly shown in any electrical motor. If you had a chance to use or to see an electrical motor, like this electrical motor here. This motor, it has some rotors and stators parts. The rotor part, it is connected to a shaft. So this is known as the motor shaft. This is the motor shaft. Motor shaft. And motors, these are the source of power. This is what gives power to any machine. Any machine to work, it requires engine like a car, or it requires an electrical motor like any other machine that is stationary in place. So the motor, to give power and operate any machine, there should be a little bit small shaft that is projected out of the motor. We cannot see what's inside the motor because of the housing. So this cover, this entire cover, there are lots of things inside the motor that are not seen. Because of what? Because of the housing. So this is the housing that I'm talking about. This is the housing of this electrical motor that cover the entire components inside the electrical motor. There is only one thing that we can see is the shaft. This shaft has a spline. Do you see these grooves which are parallel to the shaft? These are the splines. This spline will allow us to easily mount in any gear or pulley or anything to the shaft, so we can transmit the power. It is transmission of power. We are transmitting the power. We do have a source of power, and we need to move this power from one location to another location. Move this power from the electrical motor to the wheel of the car, or to a rotating shaft inside the machine. So in order to move or to transmit, it is known as power transmission. In order to transmit this power from the source of power to other mechanical component, we should use some mechanical elements in between. These mechanical elements, some of them are the shafts, some of them are the gears. Make sense? So like this shaft, it should be made with a spline. This is how it comes with the motor, and that allows for the easy mounting of any gear to the shaft of the motor. So once the motor operates or rotates, it's gonna give rotation to this shaft, and this shaft is gonna give rotation to the gear that is fixed over this shaft. This is the function of the shafts or the spline that would be shaped and formed over the shafts. So the general mechanical component is the shaft that would be blank without any splines, or it would be with a spline. Make sense? Other mechanical components that would be used for mounting other mechanical components are fasteners as a structural component. Fastener, if we're going to talk about bolts and nuts, any screw, whatever it is one of the types of the fasteners that used for fastening things together, for holding two different mechanical components together. Remember, like for example, fixing one plate to another plate, like you do have two separate parts and you would like to collect them together, join them together. We can either weld them. Welding, it means that you're gonna make them like a single part, or you can easily use bolt and screw and nut to hold them together. So this is the objective of the fasteners in general. Any machine, even if you try to bring any exercise machine at home, definitely it should contain some screws and some things to join things together, right? So any machine, it should include some bolts, some nuts, some screws to hold parts together. So fasteners are mainly used for joining mechanical components together through with the aid of screws. And we do have different types of screws, but these screws would be used as bolts. This group here, this box here, these are the bolts, and these are the nuts. So these are the males and these are the females. Like you're gonna use a bolt and a nut to mounting two pieces or two parts together. Like for example, you're gonna have one part in this way and you're gonna have another part, and then there should be a hole through both of them. So you're gonna use one bolt, the bolt is gonna go through the hole. This is the bolt that has the screw in this way, and from the other side you're just gonna add here a nut. So this is gonna be the nut, the other side of the screw, and this is gonna be the bolt. So the male, it is usually named bolt, and the female, it is the nut. So this is how we can fasten two components together or hold two components together. This is the objective of the fasteners. Make sense? Also, we do have seals. Seals, these are the used for controlling the fluid flow in certain direction under certain pressure. So this is, for example, one of the typical forms and shapes of a seal, that it has a spring, and this is like a rubber seal part, that like rubber cap that closes this opening. Like this example, we do have here this rotating pump. This is like a rotating water pump, and there should be like inlet of the water, and there is another outlet here, and the seal, it is fixed here, and there should be like the screw. So at certain pressure, I'm sorry, this is the spring. So this is like an elastic thing. This is a spring that it will be compressed and stretched back. So at certain pressure, you are applying a certain amount of pressure, and we design this spring to support a certain amount of pressure. When the pressure, as it increases, this spring will be compressed. It can push back, compressed back, to allow for more oil to be flow over this opening. But if this pressure is lower, this spring will stretch back again and will close this inlet. So this is one of the applications for which we would use seals, but seals are used a lot. So seals are things that would give either, we could use them, for example, to prevent the flow of oil or any liquid material inside the machine. For example, in your car, the transmission system of the car contains oil. When you do the service for your car, you're gonna go to the service company and they're gonna change the oil after a certain amount, like after 3,000 or 4,000 kilometer per hour, kilometer, you should change the oil, right? Inside the transmission system. So the transmission system, it is like a box. It is like a container that filled with oil. So there should be some seals that use for preventing the leak of the oil, for preventing the flow of the oil outside this transmission system. In some other system like this pumping system, we could use the seals to control the flow of the fluid in one inlet from one input to another output, from one inlet to another outlet. Make sense? So this is the function of the seal. This also one of the mechanical component, and there are more. So what we have discussed so far, we discussed the most common types of structural component like frame members that give support like the chassis of the car, bearing that give support to the shafts, axle that give support to rotating wheels, splines and shaft that give support to the gears, and the fasteners in addition to the seals, and there are more. There are more and more structural components, but in general, what is a structural component inside in a machine? This is the component that in many cases is gonna be immovable. But in some cases itself it could be movable, but the key idea is that this structural component, it will be used for giving support for another mechanical component who is rotating. Like shaft gives support to rotating gear and so on. So that's why shafts and splines are included into this list. Make sense? So now what we discussed the different structural components. In addition, now we're gonna move to the mechanism. As we define the difference between a structure and a mechanism, the structure, there is something in many cases that cannot move, like the bridge and a mechanism. But despite this definition of the structure, we have included shafts, right, as a structure, mechanical component. Why? The shaft, it could be considered as a part of the mechanism, by the way, and also it could be considered as a part of the structural component. Why? The shaft, it rotates, so it can be counted as a mechanism. Why? It is movable, it can move, it rotates, so it can be counted as a mechanism. But in the meanwhile, it gives support to another rotating mechanical component, so it can be counted as well as a structural component. The same thing, the bearing. It can be considered as a part of a mechanism. Why? It rotates, but in the meanwhile it gives support to a mechanical component who is rotating, which is the shaft. It means that also it can be counted as a structural component. Make sense? So structural mechanisms. So let us discuss the mechanism definition. A mechanism is a mechanical device. In many of the cases, it's gonna be device. Device, it means that it's gonna be a mechanical system. Any device, whatever it is not just one single part. It is multiple parts that assemble together, work together to provide a device or to provide a mechanical system, small mechanical system inside the big mechanical system, which is the machine. So for example, if we're gonna talk about the gear train, it is not one single gear. It could be like a group of gears that work together, like the gearbox. The gearbox, it is not just one gear. But for example, if you have something wrong, this gearbox, like the transmission system of your vehicle. If the transmission system of your vehicle it is bad and it should be changed, so you're gonna go to the company and bring another one, right? So you're gonna ask for a new transmission system for your vehicle, and you're gonna get this transmission system like a single unit, like single thing, right? But if you open it and you're gonna look inside it, you're gonna see multiple gears, multiple shafts, multiple bearings, and so on. So we're gonna say that this is transmission device or subsystem inside the big system, which is the vehicle. The overall system is the vehicle itself, is the car. This car, it contains some small mechanical devices, some small mechanical systems, like the transmission, it is a mechanical device or mechanical system. Like the clutch, it is a small mechanical device inside the big device or inside the big system, which is the vehicle. Make sense? So a mechanism in general, it should be made of different mechanical components. It should be made of multiple mechanical components. The mechanism cannot be made by a single component. A single mechanical component by itself cannot make a mechanism. A mechanism should have multiple components who are working together to provide a device, to provide a system to be a mechanism. So that's why we define a mechanism as a device, as a mechanical device, as a mechanical system that is used for controlling motion and converting motion from one type to another. The main functions of any mechanism the functions of the mechanism are used inside machines, are used for controlling controlling motion and speed of your vehicle, of your machine or whatever. Also transmitting power and energy between the different mechanical components, different mechanical components inside your machine. Also, it could be used for converting the type of motion. For example, what is controlling motion and speed? For example, if we're going to talk about the transmission system in your car, in your vehicle, this is the controller of the speed. How you control the speed of your vehicle is through the transmission. If there is something wrong with the transmission, in many of the cases, the car won't gonna move. Or there should be something wrong in the controller, in the controller of the speed of your car. It means that the transmission is the controller, or what gives speed regulations. It's known as the speed regulation, is to give you the freedom as a driver to change the gear, to change the speed, to speed up, slow down. All these things come through the transmission system of your car. So the transmission system, it is a mechanism that gives control to the motion and the speed of your machine. Also, the transmission is used for transmitting power from one place to another place. We said that any machine, it should have a source of power. And this power and energy should be transmitted to the other components inside the machine. What is the thing that would be used for transmitting power and motion from one place to another place? You require a transmission system. Also, transmission system or mechanism could be used for converting the type of motion. What is the types of motion? You may have something that is rotating inside the machine. You may have other component that is moving linear in a straight line, like horizontal or moving vertical. So this is linear motion, but this is rotating motion. So we do have different forms and different types of motions. How we can switch between them? How about if you do have a rotating motion and you, for some reason, you would like to convert this rotating motion into a reciprocating motion, like something that moves forth and back, and so on. So how you could convert a rotating motion into a linear motion, or a linear motion into a rotating motion? You need something to do so. You need a mechanism. So mechanisms are used for many things inside the machine. You could say that the mechanism, this is the heart of the machine. This is everything. Machine without a mechanism is not a machine. It is like a bridge. It is just a structure. What distinguishes the bridge from a machine is the mechanisms that are included inside the machine itself. So a mechanism, simply, it is a mechanical system or a mechanical device that used for what? Used for controlling the motion and the speed of the machine, converting motion from one type to the other type, transmitting power and energy between the different mechanical components of the machine. This is what the mechanism is. We do have so many types of mechanisms. It is not just one mechanism that's used for all machines. No, every single machine, it has its own mechanism or set of mechanisms. It is not necessary to be only one mechanism inside one machine. No, you may have inside one single machine like 10 or 7 or more mechanisms. This depends on the machine itself. And these mechanisms are different. So in general, for different mechanical system, for different machines that we are using as engineer, we do have bunch, we do have so many mechanisms. Some of them are the gear trains or the gearboxes, belts and chains, chain drives, linkages, cams and follower systems or mechanisms, brakes, the couplings and clutches. So these are the common things, and this is what we are going to discuss over the next few slides. Make sense? So the first mechanical component that would be used for making mechanisms are the gear trains, or these gear trains. This is like a mechanism itself that contains gears. So gears are one of the essential type of components, mechanical component that you would be used for making mechanism, and this type of the mechanism is known as the gear train or the gearbox in general. as it is already commonly known. So let us discuss the gear train. This is what we're gonna cover today. Then the other mechanical elements, we're gonna discuss them over the next video. So as for the gear trains these are like commonly known as the transmission box in your vehicle, or commonly known as the gearboxes or the gearbox. The gear train, it is a mechanism that mainly contains gears, and we do have so many different types of gear. And what is the objective of this transmission system in general? So let us have a very quick introduction about the gearbox and their importance, especially for an important application like your vehicle, for the car application, automobile application. So generally speaking, since we are talking about a machine, and remember that your car is just a machine. Any machine, it should contain three main components. Any machine, whatever it is, it contains three main parts. Source of power, something that gives power to operate this machine. Without this source of power, there is no machine. The machine won't gonna be able to work. There should be a mechanism that used for transmitting the power from the source of power to another. This is the third part, which is the operating element. Like if we're gonna consider your car as an example, what is the source of power in your vehicle? What makes your vehicle moves? The engine of the car itself. This engine, it is heat combustion engine that you work by burning and generating power by burning fuel. So it is a special mechanical engine that used for generating and giving power to your vehicle to move. So this is the source of power. The engine is the source of power. And there is a transmission system, which is the transmission in your car. There is a mechanism. This is the main essential mechanism that used for transmitting the power from the engine, which is the source of power, to the operating element. What is the operating element in your car? The operating element is the wheel. The four wheels in your car, this is the operating element. We may have a car that is front wheel drive. What does it mean, front wheel drive vehicle? It means that the two front wheels, these two wheels are connected to the transmission, connected to the engine, and once the engine is working and the power is transmitted to the wheel, the two wheels are the ones that receive the power from the engine. But the other rear wheels, they are just moving with the movement of the car. If the car is moving, they are rotating. If the car is not moving, they are not rotating. So they have no function except giving support to the car. These are the rear wheel in case. Here we are talking about front wheel drive vehicle. It means that all the motion comes by giving rotation to the two front wheels. It means that we are designing the transmission system. We are designing the car to transmit the power from the engine, which is the source of power, to the two main operating elements, which are the two front wheels. We may have another type of car, or vehicle, which is rear wheel drive vehicle. Rear wheel drive vehicle, it means that the other wheels on the back, the rear wheels, who are the one who are giving motion to the car. And the two front wheels, they are just giving support to the car. They are rotating if the car is moving. They are not rotating if the car is not moving. They have no function except giving support to the car. This is the essential function of the two front wheels. But all the motion comes from the two rear wheels in case that the car is rear wheel drive vehicle. We do have cars which are 4x4. Car 4x4, it means that 4x4 vehicle, it means that all the four wheels are giving motion to the car, and they do contribute to the motion of the vehicle. And all the four wheels are connected to the transmission system of the vehicle, which takes the power and the motion from the engine of the vehicle. So this is how any machine, if you could able to map these three main parts of your vehicle, they're gonna be the same for any other machine. Any machine in general, it contains three parts. Source of power, which would be an electrical motor, in case that we are talking about any electrical machine, or any machine that is fixed, or an engine like the engine that used in your vehicle. Plus, there should be a mechanism. This mechanism in many of the cases is gonna be a transmission system. This mechanism is responsible for transmitting the power from the engine to the operating element, for controlling the speed, for controlling the motion. All the control of the movement of your vehicle comes through the transmission system. Plus, there should be operating element, the thing that you're gonna operate, the thing that is gonna give motion to your car. Your car won't gonna move unless you rotate its wheels. If the wheels are rotating, the car is going to move. If they are not rotating, there is no movement for the car. Makes sense, right? So these are the three components for any machine, whatever it is. So if we try to consider the application of the automobile, an automobile or a car, for example, requires high torque and power. Torque, power, energy, they kind of related. This torque or power or energy comes from the source of power, comes from the engine, comes from the motor. So any car requires a high amount of torque when climbing hills and when starting the engine or the car to move, even though they are performed at low speed. For example, if I ask you to drive the car, assume that if any one of you have any previous experience with the manual car, manual drive car, not automatic cars. Automatic cars are very easy to drive. But if we're gonna talk about the manual car that require that you shift between the first gear, second gear, third gear, and so on. These manual cars, if I ask you to drive the car, what you should do, you should first of all switch on the engine, operate the engine, then you're gonna shift the gear to the first gear. The first gear, this is the lowest speed. This is the lower speed. Right? Why you are shifting to the first gear? I didn't move yet, right? But you have to shift to the first gear, then you're gonna remove your foot. You're gonna use 2 foot. One, it will be completely pressing the pedal for the clutch. Then you're gonna apply the gas steadily and you're gonna remove easy step by step the pedal of the clutch, right? To give transmission to the motion so the car could move. So the question is, why you should shift? The car didn't move yet. Once you switch on the engine and you start moving the car, why you should shift to the lower gear? You should shift to the lower gear because the car requires high torque to move. The car is still stationary, not moving. The car has zero momentum. The momentum, it gives the ability, easy movement for any object that is already moving. So the momentum is related to the speed of the object. The car initially, it has zero speed, is not moving, stationary. So this requires very high torque to give push to the car to start the movement. So that's why when you start moving the car, if you are using a manual car, you have to shift to the first gear first, which is the lower speed. So there is inverse relation between the torque and the speed. If you require high torque, you have to lower down the speed. If you need high speed, you have to lower down the torque, and so on. The same thing if you are driving the car above the hill. If you're already climbing a hill with your vehicle or your car, especially if it is very sharp, you have to shift down to the first gear. The first gear, this is the high torque. This is what gives the highest torque to the vehicle, so it could move. But once the vehicle it moves, on the other hand, when running at high speed, if the car is already running at high speed, it requires lower torque. High torque is not required because of the momentum. Any simple torque can keep moving because the function of the torque in that case is just to keep the car moving. The car is already moving at high speed. So the amount of torque in that case that is required to keep the momentum of the car or to keep the movement of the car, it will be lower. It will be low. So that's why at the higher speed, that is fine to shift the gear to the second, to the third. As you speed up more, you're gonna shift the gear to the higher gear. You're gonna shift to the second, third, fourth, fifth. It depends on the car till you're gonna reach the maximum speed of the vehicle. So as you speed up, it means that the torque that required from the engine it will be lower, or the required through the transmission system will be lower. Why? The car has its own momentum, so you just require or need the torque just to push it to keep it moving. But to initiate the motion, you require higher force, so that's why you have to shift to the lower gear. Make sense? Also, something that you know about this vehicle, a device is required. So based on this data, in order to do all of these different things, so as you can see, in some cases, in some scenarios, we may require high torque. In some other cases, we may require lower torque. We may have very low speed, we may need to shift to a higher speed, right? So you need a device, you need something to give you this freedom, to give this control, to give control of the speed, the torque, and the power transmitted from the engine to the wheels of the vehicle, so it could move. So therefore, a device or a mechanism is required to change the vehicle's torque and speed according to the road condition and the driver's need. If you are driving a hill, you have to shift down to the first gear or the second gear at maximum, because you require high torque. If you would like to speed up, you're gonna shift to the third, the fourth, or the fifth gear, because you require lower torque and you need to run, you need to speed up the car. Make sense? So this shifting between the gears, this mechanism require a special mechanism to do so. To this control of the torque and the speed, this mechanism is known as the transmission system of your vehicle, or commonly known as the gearbox. This is the gearbox in your car. You can apply the same concept to any other machine. Any machine, whatever it is, also it contains, in many of the cases, a mechanism as a gearbox. This transmission system is used for speeding up the machine, lowering down the machine speed, increasing the torque, decreasing the torque. It depends. It depends on how do you use the machine, how this machine is working. Make sense? So this is, generally speaking, what are the main three components of any machine, and you do have a similar thing. So this is like a typical shape of a gearbox that would be used for the transmission system of a vehicle. That we receive the power and the motion from the engine. Usually the movement comes from the engine or from the source of power, which is an electrical motor or an engine of a vehicle, that gives rotation to some gears. All of these, they gonna rotate together to give motion to the operating element. So the motion and the power comes from the source all the way till the operating element. Make sense? So this is the function of the gear train or the gearbox in general, as one of the essential components that would be used for vehicle or automobile application. Make sense? What we're gonna do here, we're gonna discuss the different types of gears that would be used for gearboxes, for making gearbox. So since we do have the name as a gearbox, it means that the gear, it is one of the essential components of making any gearbox. But this doesn't mean that the only gear is the thing that is used for making a gearbox. No. The gearbox contains gears, clutches, braking system, couplings in some cases, bearings. So many other mechanical components are included inside the gearbox. But the most common of them, as the essential component for making this gearbox, is the gear itself. So that's why we got the name. But generally speaking, this is a transmission system that used for transmitting the power and the speed from the source to the operating element in general. This transmission system would depend on some gears. If it depends on gear, it's gonna be named as gearboxes. Make sense? So a gear or gears are mechanical elements. So the gears, a gear is a mechanical component or a mechanical element. It's just one element, because you here we are talking about a gear. I'm not talking about the entire gearbox. The entire gearbox contains so many gears, so many shafts, so many clutches, so it is a system, it is a device. But here I'm talking about just the gear. The gear is just a mechanical element or a mechanical component that is usually used to convert a rotating motion to another rotating motion with the same or different speed. We mentioned that a mechanism, one of the functions of any mechanism, is to convert the type of motion from one type to another type. Or you could convert to the same type of motion but different speed, as the case of the gear. The gear, you do have two gears like this case. This is one gear, and there is another gear. Both are meshed together. Meshed, it means engaged or connected together. One drives the other one. One rotates the other one. So these two gears, or each one of this gear, gives, this gear rotates. So the type of motion of that gear is rotational motion. And the other gear also rotates. So this gear transmit or gives rotation to the other gear. So we didn't change the type of rotation. We didn't change the type of motion. Both still are rotating, but we are changing the speed. So this is the key idea. So the gears are mainly used for converting rotary motion or rotational motion to another rotational motion, in many of the cases with different speed. We, in some special cases, we could even keep the speed as it is. So we weren't gonna do changes to anything in terms of speed, in terms of rotation. But if we have this option, it is not wise to use it, but in many of the cases we have to do changes. We have to change something, either the type of motion or the speed. So gears cannot change the type of motion. Gears are mainly used for converting, for giving the same type of motion, rotation, but with different speeds. If you change the speed, automatically the torque is going to change. Torque is related to the power and energy. Torque is required to give push to the engine, push to the wheel, push to the vehicle to move, as we discussed over this slide. So as you change the speed, automatically the torque is going to change. Make sense? It is not possible to fix the torque and keep and change the speed. No, both are related. If you are changing the speed or the torque, the other one is going to change automatically. Gears can transmit power or energy and speed between two parallel, perpendicular, or mutual rotating shafts. Mutual non-intersecting, like you. We do have some types of the gear that would be used for transmitting power between two parallel shafts. Like this is one shaft and this is another shaft. Remember, what does it mean shaft? This is the shaft that I'm talking about. This is a shaft that gives support to gears. So you're gonna fix one gear over this shaft, and you probably have another shaft that is parallel to it, and there is a gear that is fixed over the other shaft. So this is like shaft one. This is the first shaft, and there should be here another shaft. This is shaft 2 that gives support to a gear. So there should be a gear here. So in order to transmit the power and the speed from this shaft to this shaft, you require to engage these two gears together to transmit the power from one shaft to the other shaft. This is the function and how gears are working in general. Make sense? So gears could be used for transmitting power between two parallel shafts. You may have one shaft that is parallel to the other shaft, and you're gonna mount in one gear here, another gear on the other shaft, and these two gears will transmit the power between two parallel shafts. Or there are some other types of gear that would be used for transmitting the power between two perpendicular shafts. Like one shaft is directed this way, and there is another shaft that is perpendicular to it. So we could use some gears here at this junction here to give rotation for one shaft with respect to the other one, which both are perpendicular. In some cases, we may have two mutual rotating shafts. It means that non-intersecting shafts, non-parallel. So they are not parallel, they are not intersecting or perpendicular, but instead they are non-intersecting in this way. Like one is oriented with the other one and there is no contact between them. So we're gonna set up some gears between these two mutual shafts to give them rotation or transmit the power and speed between them. So generally speaking, gears are mechanical components or mechanical elements that are used for transmitting rotary motion to another rotary motion of the same or with the same or different speed. And they are used for transmitting power and speed between two parallel, two perpendicular, or mutual perpendicular rotating shafts. Make sense? How many types of gears do we have? We have so many. The common things are, or types are, spur gears, helical gears, bevel gear, worm gear. Worm gear, this is like a mechanism by itself. It means that this is like two gears, not just one gear. But we may have one bevel gear, we may have one helical gear, one spar gear. Definitely one spar gear requires another spar gear to move. One helical gear requires another helical gear to move, but both are separate. The same thing for bevel gear. But one worm gear, this is one single mechanism that work together. It is two gears, but they should work together. Make sense? As it's gonna be clear in over the next slides. Let us consider the first type of gears, which is the spar gear. The spar gear, what distinguish, just to understand the difference between a spar gear and helical gear, is the shape of the tooth of the gear. As you can see, the tooth, this gear, any gear, whatever it is, it has number of teeth. Like this is one tooth, the second, third. If you count how many, it would be 20, it would be 32, it would be 40, it depends on the gear itself. So any gear, it has a certain number of teeth, like this, like this one, like this has one teeth, second, third, 4, 5, 6, 7, and keep counting till you finish the entire number of teeth. Make sense? So if you can observe the teeth of a spar gear, it is straight. What does it mean straight? It means that the edge of the teeth itself, it is parallel to the axis of the shaft, parallel to the shaft. So this is one teeth, and there is another teeth that is parallel as well, and so on. And the profile, what does it mean? The shape of the teeth, the tooth, it is a profile. So any tooth, it should have a specific profile, and this profile, it is repeated over all the teeth of the gear of the spar gear. Make sense? We may have the spar gear separate, or it would be crafted and manufactured over the shaft, as we explained before. Like in this case, this is a shaft with a spar gear. The spar gear, it is crafted and manufactured as a single part with the gear or with the shaft. If you try to give rotation to the shaft, if you try to rotate the shaft, this gear definitely is going to rotate. And this is how the gear would be used for transmitting motion, transmitting speed and power. Like this case, these two gears here are not fixed or manufactured over the shaft. No, they are separate from the shaft. So for example, we can mount in one shaft here, we can add one shaft there, and we're gonna add another shaft here. So these two gears will be used for transmitting power and motion between two rotating shafts, and these shafts are parallel. This shaft is parallel to the other one, right? So generally speaking, spar gears are used to transmit power between two parallel shafts. This is the power and speed between two parallel shafts. This is the main function of any spar gear. In many of the cases, the speed is going to change. So to do so, it means that you should use two gears with two different diameters. Diameter, it means, or sizes, like this gear is smaller than the other one. It means that the speed is going to change. But if the two gears are identical, having the same diameter, having the same circle, having the same size, the speed will not change, the torque will not change. But in order to change the speed and the torque, you should use two different gears, and these two gears will be meshed together. Meshed, it means engaged. The teeth of one gear will be inside or engaged with the other teeth of the other gear. And one of them is gonna be driver and the other one will be driven. Driver is the thing that is gonna push the other one to drive. One is gonna give rotation to the other one. One is gonna drive the other to move. One is gonna enforce the other gear to move. This is what does it mean, driver and driven. So in this case, this is the driver gear. The driver usually is the smaller gear. And this is the driven gear, the thing that it will be rotating upon the rotation of the smaller gear. In case that the driver is a gear and is smaller, it is commonly known as pinion. We usually give it a name as pinion. So pinion is just a gear. Any gear, it could be pinion. Pinion, it means that this gear is a special gear. It is small in size in comparison to the other gear, and this gear, it is a driver. is the one that enforces the other one to move. It means that the shaft of the pinion is going to rotate first to give rotation to the pinion. Then the pinion is going to push and enforce the gear, the other big gear, to rotate, to give rotation to this shaft. This is how this mechanism is working. So this is the pinion, which is the driver, and this is the gear of the driver. So usually this mechanism is known as pinion gear mechanism. Pinion is the driver, gear is the driven gear of that mechanism. Make sense? So again, this bar gear is just a gear with a straight tooth. The tooth of the gear, it is straight, parallel to the shaft axis, and it is mainly used for transmitting power and speed between two parallel shafts. This bar gear, it would be made or crafted over the shaft as a single part with the shaft, like this case, or it could be separate from the shaft. And in that case, it should be fixed over the shaft using something that we call as keyway or key. So if in case that we don't have this gear is separate from the shaft, so it means that you're gonna have the shaft and you're gonna mount it and fix the gear over the shaft in that way. In order to do so, you should, if you can observe this slot here, this opening, this one, and you're gonna find here a little bit slot here. This slot or opening, it is known as the keyway. This keyway is used for mounting and fixing the gear over the shaft. So how it works in this way, like it is, assume that this is the shaft. As you can see, there is something projected here. This thing is gonna be like a key. And if you do have a gear, the gear, it has like a keyway that fits and it can be engaged with this key. So when we try to mount in the gear, your objective is just to try to fit the keyway, which is this slot, to this key, which is gonna be projected out of the shaft. So both they're gonna be fixed together. When you try to give rotation to the shaft, the gear is going to rotate as well. Unless you're gonna manufacture the gear as a single part with the shaft, as already given here. Make sense? Like in this graph here, in this representation, this thing that is projected out, it is key. This is the key that is gonna be fixed over the shaft. This vertical thing, this is the shaft. And this shaft has two gears, by the way. One gear, this gear is already crafted, manufactured with the shaft. But this other gear, it can be separated from the shaft. So what does it mean? This other gear has here keyway. There should be here some keyway here in this region. So when you try to mount and fix the gear, pushing it up, this keyway will be fitted with the key that is projected and fixed over the shaft. Projected from the shaft and fixed over the shaft. This is the key itself. This gonna give, once you give rotation to the shaft, this key will enforce the gear to rotate with the same rotation as the shaft. Once the gear rotate, it's gonna give rotation to the other gear which is engaged or meshed to it. Make sense? So this is simply how the gears could be crafted and manufactured as one single part of the shaft, or it could be keyed to the shaft. Keyed, it means that it will be mounted to the shaft and it can be separated from the shaft. But generally speaking, the important thing that you should acknowledge is that the spur gears are used for transmitting power and speed between two parallel shafts, and spur gear, they do have straight teeth that are parallel to the shaft. Make sense? The other type of gear are the helical gears. Helical gear like the spur gear, but the only big difference between both of them is the shape of the teeth. The tooth here, it is straight, but there the tooth, it is helixed. It means that it has helical angle, it is aligned, it is not straight. It is inclined with a certain angle. If you just measure the angle between the axis of the shaft and the tooth itself, you're gonna find a certain angle here known as the helix angle. So that's why we got the name as helical gear. It means that the tooth, it is not straight. The tooth, it will be helixed. It will be inclined. it will be like have a helical rotation with respect to the axis of the gear or the axis of the shaft itself. This is what makes the helical gear different than the spar gear. Why we should do helical gear, despite we can do for in terms of manufacturing and even in terms of cost, the helical gear is more costly than, in terms of price, it is more pricey than the spar gear. But what is the importance of the helical gear? Helical gear can support more forces and different types of forces, more the type of forces that the spar gear can support. I won't gonna go details over these forces things, but this is the thing. Spar gear can support some types of forces. Helical gear can support more types of forces, which more than the spar gear, and that's why it is recommended over the spar gear in many of the applications. Unless you have a simple mechanism that doesn't require very high force and different types of forces, so that is fine to use the spar gear. Even in one single mechanism or gearbox, we may use both of them. We may use helical gear and spar gear. But again, what is the essential difference between helical gear and spar gear? Spar gear, they have a straight tooth, but helical gear, they do have helix tooth, like it has a helical tooth. So used to transmit, helical gears are used to transmit power and speed between two parallel shafts, like the spar gear, also used for transmitting power and speed between parallel shafts only. But helical gear can transmit power between parallel shafts. Also, they can transmit power between two non-intersecting shafts. This is another difference. So they do have difference in terms of the shape of the tooth. Also, they are different in the function. Helical gear can support power and motion, or transmit power and motion between two parallel shafts and two non-intersecting shafts as well. But spar gear can only transmit power between two parallel shafts only. Make sense? This is the difference between parallel shafts and helical gears and spar gear. Like in this animation here, this is a typical example of two helical gears that are engaged together, and both they should be helical. It means that it is not possible to transmit power between a helical gear and a spar gear. No. A spar gear transmit power to another spar gear. The helical gear transmit power and speed to another helical gear, and both these should be related together. There should be some certain relations between these two meshed or engaged gears, so they could be able to transmit power and speed. In this case, this gear, it will be fixed to a shaft that should be vertical shaft in this way. And this gear will be fixed or mounted to a vertical shaft, another vertical shaft. So in this case, these two gears are transmitting power between two parallel shafts. But here, this little small gear, it is a helical gear, and this big wheel or gear, it is also helical gear. Why? Because the profile or the shape of the teeth, it is helixed. So this will transmit power over this shaft. So this is the shaft of this gear, and the shaft of the other gear will be vertical in this way. So these like two non-intersecting mutual shafts, rotating shaft. Like this shaft of the small gear, it is directed this direction, and the big gear, it is directed in this direction. So these are non-intersecting, non-parallel. So generally it is non-intersecting mutual shafts. This is also one of the things that would be used for the helical gear. So helical gear can transmit power between two parallel shafts or non-intersecting shafts, but spar gear only transmit power between parallel shafts. Also, helical gear can be crafted and manufactured as a single part of the shaft, like the case of the spar gear. Also, they can be made separated from the shaft. It means that it can be mounted using keys as well over the shaft. This is also the thing of the helical gear and the spar gear. Make sense? The last thing that I'm going to discuss here is these two figures here. Then the next other types of gears and the other mechanical component, this is what we are going to cover over the next video. But this is the last thing that I'm going to cover here, which are these two mechanisms. These two images are images of real gearboxes. If you're gonna open any gearbox of any machine, of your vehicle or anything, any machine, whatever it is, you're gonna see something very similar to what is shown in these two figures. So this is like a typical shape of a gearbox that contain lots of mechanical components. Some of these mechanical components that we have discussed so far. If we're gonna go very quick over the previous slides, we discussed the frames, the bearings. Bearings definitely will be found inside the gearboxes. Shafts will be definitely found inside the gearboxes. In addition, into the gears will be found inside the gearboxes. In addition to other mechanical components, which we'll discuss over the next videos. Make sense? So let us look to these figures, which would seem unclear to many of you, and try to collect the different mechanical components that we have discussed so far. We discussed in these figures we should find shafts, bearings, and gears. So your objective is just to try to allocate the different gears, allocate the different bearings, allocate the different shafts that we discussed over these two images. Can we do so? Let us try this one. So for example, if I ask you how many shafts do you see in this figure? First of all, you should know and acknowledge the function of the shaft. The shaft, it is used for supporting gears, to give support to gear to rotate, right? This is the function of any shaft. Like this thing is a shaft. So if you're gonna look here, we do have so many gears, definitely all of these things are gears. So this means there should be one shaft supporting this group of gears, right? It means that this thing, this shiny thing in between, cylindrical part here, this should be the shaft that starts from this point all the way till the end, which is not shown. So all of this thing is just one single shaft that supports so many things. Make sense? So you could say that this is shaft 1. And we do have another shaft here. There should be another shaft, right? Because there are lots of components, mechanical components that can rotate, that's supported by something here, there should be a shaft. If I ask you to locate the body or the shaft itself, this thing, do you see these dashes here? These grooves, these are splines over the shaft. So this is a spline shaft, but this shaft is blank. This shaft has no spline over this surface, has no spline over this part. But there is a spline here. Over this part, there is a spline. Over this part, there is another spline. But the black thing with the white or gray dashes or lines, this is another mechanical component that we didn't discuss yet. So this is a mechanical component which is fixed or mounted over the shaft or supported by the shaft. This is another mechanical component, another mechanical component, another mechanical component. Then this is the spline of the shaft itself. This is the body of the shaft. And then we do have another mechanical component and other mechanical component. But in general, in this region, over this line, there should be another shaft. So this is the second shaft. We do have a third shaft, by the way. This third shaft is this thing, all of this thing, like including this flywheel or this housing, and inside it is mounted or supported over something or over a shaft, and this should be a gear. Definitely, since there is a gear, this gear should be supported by a shaft inside it. So there should be a shaft here all the way that gives support to all of these different mechanical components. So this gives a third shaft. This is the shaft number 3. Make sense? How about if we decided to locate the shafts over this thing, over this gearbox? This is another gearbox. So as you can see, there are some gears here, right? And there should be this thing here. This is the body of the shaft. It means that there should be a shaft here. And this is the rest of the body of that shaft on the other side. Here there should be a shaft in the middle, right? These are different gears that supported and things are supported over the shaft. It means that there should be a shaft here and there should be another shaft. Both are considered in terms of axis. They do have the same axis, but in many of the cases they would be one single shaft or two separate shafts. But we don't know exactly. This depends on the other side of the gearbox, which is not shown. But anyway, you can deal with them like two separate shafts or just one shaft. It doesn't matter. Also, we do have another shaft here. Do you see this tip, this cylindrical tip, this all the way, this thing? And then the diameter is going to increase somehow. Then it's going to increase a little bit, right? And it's going to increase somehow. Then you're gonna all the way till the end, till you're gonna end up with almost the same tip on the other side, right? So all of this thing, it is one single shaft. This is one entire single shaft. Okay, so far we have located three shafts. Also on the back here, there is another fourth shaft. This is shaft number 4 on the back. We do have another shaft here on the back. There is another one here. So all of these are different shafts. And also probably there should be another shaft because there are some gears located inside here. But anyway, once you find a gear or any mechanical component that would be rotating, this requires a shaft inside the gearbox. Make sense? So shafts is one of the essential mechanical components that definitely will be exist inside any gearbox. In addition to shafts, there should be bearings and gears. Bearings, as we mentioned before, bearings, they give support to shafts. Any shaft, it should be supported by at least 2 bearings. Should be supported by at least 2 bearings. So for example, since here we are talking about this is like one shaft, right? We have located one shaft here. Can we locate the bearings, the 2 bearings of this shaft? This shaft to be supported require 2 bearings. These 2 bearings are these 2. This is one bearing. This thing is one bearing. This is bearing 1. And there is another bearing which is identical to it on the other side. This is the other bearing. But this bearing, it is different than the type of bearing that we have discussed here. This type of bearing, it is known as ball bearing. Why? It gives support, it gives free rotation of the inner ring with respect to the outer ring through spherical balls. We could replace these spherical balls with cylindrical rollers. But this type is known as ball bearing. This is known as ball bearing. We could replace this thing by cylindrical rollers that could be used also for giving free rotation of the inner ring with respect to the outer ring, as the case as already shown in this figure. So this picture here, this type of bearing, it is rollers. It replaces the spheres with cylindrical rolls. So that's why also this is one of the types of the bearing. And these are the 2 bearings. This is one bearing and there is another bearing on the other side that gives support to this shaft. Make sense? How about the second shaft? Can we allocate the bearings over this shaft? Yes. There are some of the bearings which are clearly seen. This golden thing, this golden thing, it is a bearing, which is very similar to this thing. Also, it has cylindrical rolls. So this is a bearing. This golden part is a bearing. This is another bearing. This is another bearing here, right? But how about this shaft? There should be another bearing here, but it is not seen. It should be located somewhere over this part. Make sense? So all of these are different bearings. So this golden thing are bearings. This is also bearing. How about this part here? For this figure, the bearings are not clearly seen, but you should acknowledge or understand that this part here, this cylindrical part, it is a bearing for this shaft. And this cylindrical part here, it is another bearing for this horizontal shaft. And there should be some bearings inside this housing here, but they are not clearly seen as for the case of these roller bearings. Make sense? In addition to bearings and shafts, so since there is shaft, there should be bearing. And then there is shaft and bearing, there should be gears. All of these shafts and bearing are used to give support to the gears mainly. So can we locate the 2 different types of gears that we have discussed so far, spur gear or helical gear? Yes. So for example, if we're gonna look to the first shaft here, this is a gear. The tooth of this gear, it is inclined, it is not straight like this bar gear. So this means that this gear, it is a helical gear. Here also we do have two helical gears side by side, two of them. If you can observe the figure very clear, you're gonna find that these are two different gears, not just one gear. And both they are helical gears because their teeth are inclined, their teeth are inclined and not straight. It means that they are helical gear. Also this gear, there is a small gear here. There is also helical gear that is crafted over the shaft. This gear is made as a single part with the shaft. Over this entire shaft, there are two gears. These things, these black things in the middle, these are not gears. Forget about these things. Just focus over this thing. This is a helical gear, right? While the tooth, it is inclined. Here the tooth, it is helix or inclined. It means that there is another helical gear over this side. So this is a helical gear. There is another helical gear. This big gear, it is helical gear. Its tooth, it is inclined. So over this video, we have succeeded to locate shafts, bearings, and gears. These things are essential mechanical components that would be used for making a transmission system, for making a gearbox. Make sense? Over this side also, we do have helical gear. This gear here, it is a helical gear. Its tooth, it is inclined. Also, the other one that is engaged to it, it is helical gear. Its tooth is inclined. There is a helical gear. This is also a helical gear. There is another helical gear here. Also, there is a helical gear. There is another helical gear. So all of these are helical gears. This is a helical gear. There is another one, helical gear. There is another one, helical gear. There is another one, helical gear. But how about this thing? Do you see this thing here? This thing in the middle? This is known as clutch. This is a clutch. This is a mechanical component that we didn't discuss yet. We are going to discuss it over the next slides. But this is a clutch that would be used for switching the speed and switching the motion between different gears, as it will be explained over the next video. Also, this is another clutch. Also, this is another clutch inside this figure. So one of the things, this is the objective of this video, this is the objective of this lecture, is just to give you an idea about these different mechanical components, and at least to look at this figure. And once you see, I believe that once you finish this video, once you look at any gearbox, you could at least allocate the gears, the shafts, the bearings, and know what is the function of these different mechanical components and why they are there inside a gearbox. Make sense? This kind of knowledge and information is essential to know if you decided to work or do anything that related to the design of a mechanical system. And this is the objective of this part over this video, and the next video is to show you these different mechanical components and the function of every single one and how we are using them for different mechanisms for different machines. Make sense? So that's it for today. This is what we have discussed over this video. The next meeting we are going to continue the other types of gears like bevel gear, worm gear. Then we're gonna move to the other mechanical element that would be used for making transmission system like belt chains, linkages, and other mechanical component. Then we're gonna discuss also the transmission system of the manual vehicles, how they are working, how these mechanisms are working and operating, how we could shift between the first gear, second gear. All of these details will be discussed over the next video. All right, so that's it for today, and thank you so much for the watching, and see you on the next time.